Assalamualaikum. So we will continue our lecture on solar radiation. So this is the third part, which is the last part for solar radiation topic. So previous one we have calculate our example until we find the angle of incidence. So now we will continue into the after we find the angle of incidence, we will find the direct normal radiation, which is the GND, direct radiation, which is the GD, diffuse radiation, reflected radiation, and total solar radiation. So basically, all this part will be using a formula that I have. But the first one that we need to calculate also, we have to find from the T sol until we find the angle of incidence. So let's go and look into the example. So for this example, we still will use the table of solar data for 21st day of each month and then the outdoor design condition data. So the formula that we are using to use will be the normal radiation, which is the GND. So GND will be, the formula is A, which is the apparent solar radiation, AMS equals 0. So the A value, the B value, and the beta you are using, we get from the calculation that we are using. Do you remember the sign beta? So the beta one will be from the calculation. For A and B is from the table here. So this is the value of A and then this is the value of B here. So the value of A and B is apparent solar radiation, MS equals 0, and B atmospheric incidence. So after that, we are going to calculate into GD. So C N is a ratio. So how to get C is from the table. This is the value of C. We are just going to get the data from the table and then put into the formula given. So GND is from the calculation, the previous calculation here. Then the cos theta is from the calculation. GD is C from here to put. GND is from there to put here. So same goes to GR. And then the FWG, how to calculate? This is FWG formula, 1 minus cos sum divided by 2. So tilt angle is 90 divided by alpha. So this is given by the formula. And the example, the calculation, right? So the total radiation is just add GD plus GR. This is the total radiation. Alright, for the first example, we want to find the total radiation for vertical surface at 4:30 p.m. at Bandar Baru Bangi, facing southwest. So it should be 45 degree on 21st of October. So this one I can go fast because I know you guys already familiar with the find solar time until angle of incidence. So the first one we have to find the T sol. The T standard is 4:30 p.m. It's all 16:30 p.m. 120 is constant. 101 degree is based on Bandar Baru Bangi. And then the 80 is from the table also. Right, so find 1533, and then we have to find the H hour of angle. So T sol here is 1533 since it is more than 12. So 1533 minus 12, 3 hours 33 minutes. So 33, you as usual 33 divided by 60, you get 0.55 minutes. So that's why 3.55 hour times 15, which is quite constant. Alright, so then we have to find the solar altitude angle of beta. So from here is cos L. Cos L is latitude, right? Latitude is based on the table of Bandar Baru Bangi. 2 degree and 56 minutes from the table. Right, next one is Bandar Baru Bangi, 2 degree and 56 minutes. Then cos H, which is cos H is from the table, and then cos alpha is into the month, which is in October. So it is on October. Declination of degree of alpha is minus 10.5 plus sine. This is the L, and then this is the alpha. Alright. So you get the beta, shift sine the beta, and then you get 35.37 degree. So next one, you have to find the solar azimuth angle. As usual, the beta value is from here, the L is from the table of Bandar Baru Bangi here, and then the alpha is from the table, which is in from the month of October, right? So cos beta from the table, L. So we got the value of solar azimuth angle 74.92 here. Alright, so this is one quite crucial one. So cos theta is cos beta plus cos gamma here. So we have to find the gamma value first. The gamma value is phi plus minus the lambda. So the lambda is given from the question. It is 45 degrees since it is vertical. So we assume it is 45 degree. So either we want plus or minus. So remember, solar azimuth will be always measure from the south. So since this is evening 4:30 p.m., so either here or here. So we have calculated previously, it is 74.55. So measure from south to here is 74.55 here. So the lambda will be here. It is 45 degree here. It is located here, 45 degree from the south. Vertical south, 45 degree west. It is 45 degree. So the value of value here will be gamma is 29 degree 45 minutes here. So the value of gamma will be put here. Cos beta is from the table previously, from the calculation that we are calculated previously, and put here, and then we have angle of incidence is 45.08. So this is we get until the solar azimuth from the angle of incidence. Right, so next one, we are going to move into the one topic that we are calculating in this topic, which is we want to find the direct normal radiation, which is the GND. So from the table, the A value for Bandar Baru Bangi, right? So this is the value of the month of October here. So the month of October here, A, B, C will be from here, right? A, B, C is there. The value of A is from the table of October is this one 369.7, and then this is the exponent value. You just put into your calculator the value of exponent. This is the value of B on the month of October. So this is referred to the month of October here. So the value of B is 0.152 divided by sine beta. So sine beta is from the calculation, previous calculation here. So you get the answer of GND is 284.32 BTU hour feet square. So next one, after we calculate the GND, we have to calculate the direct radiation, which is the GD here. So GND value will be put here, and then the cos theta here. So the cos theta is based on the previous calculation, 45.03 degree. This is the value of that we are going to put into the value of direct radiation of GD here. Then next one, we have to calculate until the fused radiation. So this is the value of GD. GD is equal to C. C is from the table of month of October here. right? The month of October here, which is 0.11 times the GND value from here. We just put into here, and then we get the value of GD here. So the next one, we have to find the total solar radiation. Since there is no reflected or what, so we just directly add the GD diffuse GD, which is the direct radiation, and then the diffuse radiation to find the total solar radiation. So the GD is 200.939 plus 31.55, and then you get the answer of total solar radiation. Right? So this is the example, one example. So see you next video for the next example, second example.